Okay, good morning and thank you for joining. Welcome to the webinar Cloud Architecture and Design hosted by Cloud.in. I'm Suvarna Jadhav working with Cloud.in as a strategic partnership and alliance manager. For today's session, we have Ms. Rutuja and Mr. Vishal as a speaker. Rutuja is working with Cloud.in as a cloud consultant. She will guide us about cloud architecture, core components, and cloud service models. Vishal is working as Cloud Solution Architect at Cloud.in. As a part of Solution Architect team, both have expertise in delivering solutions by employing AWS best practices, leveraging wide range of available AWS services. Vishal will walk us through the AWS well-architected framework and customer use cases. I will request Rutuja to start the presentation.
Uh, Thank you, Suvarna. Hello, one and all. I'm Rutuja, and I will be giving you a brief about what is cloud computing architecture and its components. So let us first begin by understanding the agenda for today's session. So firstly, we will be covering what is cloud architecture mainly, and then moving forward, we will be seeing the core components that we have to build an architecture. Further, moving on, we will be seeing the cloud service models that we should apply in our architecture. And later, we will be understanding the well-architected framework that AWS provides us so that our architecture complies with the best practices. And lastly, we will be seeing a customer use case to more deeply understand what basically an architecture is. So moving on, let us now understand what is cloud architecture. So cloud architecture basically refers to the different components that are engineered for like solving business problems by leveraging, or you can benefit from the power of cloud resources that public clouds provide us. These components can be related to software capabilities, databases for storage, applications, etc. And it is the cloud architecture that defines the components and relationships between them. So for example, you can take like as an instance has a server hosted and it is connected to a database to store the server's data. Also, there are firewalls included for security purposes and networks for internal resources and external internet. So you can consider this as a good example to understand what a brief architecture is about. Moving on, the complete architecture needs a specific infrastructure, a delivery model, etc., to completely be presented as an architecture. All of this combined together is depicted in a cloud architecture diagram. And the main objectives of the complete cloud architecture is to provide high bandwidth to the users, which will provide them with uninterrupted access to applications and data. So users get an agile on-demand network that offers the possibility of moving efficiently and quickly between servers and even clouds. More importantly than anything else, users get a greater network security for their architecture. So let us move on to the next slide and look into the core components that a cloud architecture should have. Firstly, we have the cloud infrastructure. This supports the cloud computing by separating the characteristics and the operations that are worked on the hardware and software components of your architecture. So the virtualized resources are hosted by a cloud service provider, for example, AWS, GCP, and etc., or an IT department in case of a private cloud, and are made available to the users over the internet or a network. So in a cloud computing architecture, cloud infrastructure refers to the backend technology components, often found in enterprise data centers, such as you have servers, persistent storage, databases, networking gear, but on a much larger scale in cloud infrastructure. Moving on, considering the cloud delivery model, which is also a major aspect in your architecture. In this, it's the most basic form. There are primarily two sections of classification that we can have here. One is the front end and the other is the back end. So the internet or a virtual network connects the front end with the back end basically. And the main part of the front end we can consider here is the user interface or the UI, which we refer to as well as the network and the computer system of the client that is used to access the cloud system from the client side. So the front-end platform of cloud computing technology is also called the cloud client, and it consists of servers, fat and thin clients, mobile devices, and tablets. The interaction takes place here. The interaction takes place through a web browser or a middleware or even virtual sessions. So this is basically referred to the client side, the one who is operating their own cloud architecture from the client side. And as far as the backend side is considered, it is the side that the service provider uses. So this includes the different type of servers, data storage systems like databases, computers, programs, and virtual machines that together form the cloud computing service. So basically, backend is you can call it like the cloud service provider, which is giving you services through whichever public cloud that you're using. So the so from whom you are using the cloud as resources, that is the backend. That's the one who is accessing the backend part of this. Okay. And moving on, we have the cloud deployment model, which is like very major part in an architecture. So there are basically three fundamental deployment models of cloud computing, which is the public cloud, the private cloud, and the hybrid cloud. So as we all know, in public cloud model, the services and infrastructure are hosted on premise of the cloud provider and are provisioned for open use by general public. So the end users can access the services via public network like internet, and the public cloud services are delivered mostly on demand. So it offers high scalability and automated maintenance, but more vulnerable to attacks due to high levels of accessibility. So like here, it is very accessible to the public. So there are risks of security, but if you I mean, if you comply best practices and apply security services, resources that the public cloud also provides you, then you can be safeguarded from the vulnerable attacks also. Coming forward, we have the private cloud model. This provides cloud services and infrastructure exclusively to a single client. The users can control and customize it to his need. This is more customizable to a specific client. The cloud infrastructure can be monitored either by a cloud provider or by the tenant himself or herself. Many companies are migrating their data centers to a private cloud to run their core business fields like research, manufacturing, human resource, etc. The private cloud model offers great levels of security, obviously, and control also. Like you can customize it to your site however you want it. And though cost benefits out to be sacrificed to some extent, but you get a very good level of security and customization to your architecture. Moving on, the most used deployment model, as we can say, is the hybrid cloud. So over here, you like get the benefits of public as well as private cloud deployment models. So this is very much in demand these days. As the name suggests, you can say hybrid cloud is, as I said, the composition of both public and private cloud infrastructure. The company can use both private cloud to run mission critical operations and the company can use Yeah, private cloud, as I said, to run mission critical operations for higher level of security, and public cloud to run wherein you can reduce the cost and optimize your cost. The companies using hybrid cloud model benefit with the security and control aspect of the private cloud that it provides us, and the offhand management and cost benefits of the public cloud that the public cloud provides us. So these were the three deployment models which are very much important to build a cloud architecture for a specific company. Moving on, we have the cloud service models. Uh, so here there are mainly three cloud service models that cloud computing provides us. Firstly is the infrastructure as a service. Second comes the platform as a service, and third comes the software as a service. So as you can see from the diagram itself, in infrastructure as a service, so what happens when it's on-prem, like the traditional you have to manage everything, as you can see in the diagram, from considering from applications, data, runtime, middleware, OS patching and everything, virtualization, servers, storage, and even networking. Everything was managed, maintained, and done by the client itself in its traditional manner. But when you shift to cloud, there are three service models that it provides. And firstly coming, we have the infrastructure as a service, wherein, as you can see, applications, data, runtime, middleware, and OS is what the client manages. But the virtualization, for example, providing you a virtual server like instances and everything, servers, storage, for example, providing you databases, and networking is done by the service provider, cloud service provider that you are using. Um, so basically, infrastructure as a service contains the basic building blocks for cloud IT, and typically provides access to networking features, computers like virtual computers or an dedicated hardware tool. It's your according to your need. It can be customized. And the data storage space infrastructure and the data storage space. So infrastructure as a service provides you with the highest level of flexibility and management control over your IT resources, and is most similar to existing IT resources. So here it is very much flexible and customizable, because half of the manual work is being done by your cloud service provider, but the customization part and wherever you need things to be customized and in your own way, those are being managed by you itself. So it is completely flexible. Moving on, we have the platform as a service. Here, as you can see, the applications and the major data of your client, of the client, is being managed by them. But the runtime, the middleware, the operating system patching and everything, updation, virtualization, the servers, storage, and networking is being provided by the cloud service provider. So platform as a service removes the need for organizations to actually manage the underlying infrastructure, usually hardware and the operating system, wherein infrastructure as a service, you have to patch, update your operating system and everything. But in platform as a service, this is all of these things are done by the cloud service provider. So this allows you to focus more on the deployment part and the management of your own applications at your end. So this helps you to be more efficient. So you don't need to worry about the resource procurement, capacity planning if your servers are uh, on high workload and like exceeding and everything. Software maintenance is not done by the client side. Patching of the like OS patching and everything, or any of the other undifferentiated heavy lifting involved in running your application is completely done by the cloud service provider. They provide you all of these services. Only the data and your own your end applications are being managed by yourself. Moving on, the easiest service model, which is the software as a service that cloud computing provides us. Over here, all the aspects are being managed by the cloud service provider itself. The from considering from the applications to the networking, the cloud service provider will provide you with an inbuilt and like completely built application. They will obviously ask you for data, but will manage the complete data, your runtime, your middleware, your operating system patching and updation and everything, virtualization servers, the storage needed for that application, your servers, everything is being managed by the cloud service provider itself. The only thing that remains for the client is to market this application basically. So as I said, software as a service provides you with a completed product in short, that is run and managed by the service provider. Basically, this is referring to the end user applications. And with a SaaS offering, you do not have to think about how the service is maintained or how the underlying infrastructure is being managed. You only have to be thinking about how you will be using that particular piece of software. So SaaS is more into giving you a complete product, and you only have to think about how to use it, how to market it, and how to get it to the real world. So these were the service models, and now I would like to hand over the session to Vishal sir. He will be giving you a brief idea about the well-architected frameworks provided by AWS. Over to you, sir. Thank you.
Hey, thanks, Rutuja, for the insightful presentation. So now that Rutuja has provided an overview of cloud architecture and design, I would like to add some more additional perspectives on this topic. Okay, so let's continue the discussion and explore how we can leverage cloud services to design and implement scalable, secure, and cost-effective solution. Okay, for your organization. So talking back about the service models, so whatever these three service models are available, I mean these are available across all three public clouds, whether it be AWS, GCP, or Azure. Okay, so first of all, how to choose a service model? It clearly depends on the use case or the current infrastructure you have. Suppose you just want to host infrastructure, you just want to host a server or a database on your on the public cloud, so you can go with the infrastructure as a service approach. But if you don't want to manage OS middleware and the virtualization or the patching part, so you can go with the PaaS approach as well. So it clearly depends on the use case and the level of control you want to have on your infrastructure, right? So yeah, again, welcome all to the presentation, and let's see the basic principles before you move to cloud, or what should be considered if you're already hosting your application on cloud, or even if you're planning to move on cloud. What are the basic principles, or more accurately called the pillars that needs to be considered? Okay, so we'll be discussing 6 pillars of AWS well architected framework here, namely security, reliability, performance efficiency, operational excellence, cost optimization, and sustainability. Okay, so these are designed to help you build and operate reliable, efficient, and secure systems in the cloud. So these pillars are essential for anyone who is looking to create cloud-based solution, or who is already on the cloud and who wants to optimize and meet the high standards of AWS. So throughout the further presentation, we'll be exploring each of these 6 pillars in detail, discussing their importance and how they work together to create a well-architected system. We'll also do the highlighting of some key best practices and design principles that you can use to ensure your systems are optimized and for the performance, security, or the cost effectiveness. Okay, so whether you are a seasoned AWS architect or just starting to learn the cloud computing, this presentation will provide you with the valuable insights, and it will guide you on how to build and operate a successful cloud-based solution. Okay, so we'll go one by one, pillar wise. So first is the security pillar. So the security pillar encompasses the ability to protect data, systems, and assets to take advantage of cloud technologies to improve your secrets. So now, what does this mean? So uh, for any cloud solution, or for any customer who is planning to move to cloud, security is a very critical aspect, and this pillar focuses on protecting the information and systems by identifying and mitigating the risk, or implementing security controls and monitoring, and ensuring that all compliances are met. Okay, so first of all, we'll see why security is important. So as I said, security is quite a critical aspect in cloud computing. So this is because cloud environments can present new security challenges on-premise IT infrastructure. So some few of the reasons why security is important is that first of all, share in cloud, you go with the shared responsibility model. Okay, so security is a part of that model, where cloud provider is responsible for securing the underlying infrastructure, the physical infrastructure, while the customer who is deploying the services on his account is responsible for securing the application and the data. Okay, secondly, there is a public internet access. So cloud services are typically accessed over the public internet, which increases the risk of unauthorized access, data breaches, and cyber attacks. So you need to safeguard your account, considering all security aspects. We will discuss that in further slides. Then as I told, data breaches. So cloud data breaches can be particularly damaging due to large volume of data that can be exposed, or breaches can also lead to significant financial losses, reputation damage, and there are legal liabilities as well. Then compliance regulation is one aspect where many industries are subject to strict compliance regulations, such as HIPAA compliance or GDPR. So if cloud service provider fails to comply these regulations, it can lead into significant penalties and even legal actions. Okay, and identity and access management is controlled by the cloud service provider itself, where the owner of the account sets some rules, or some strategies, where the identity of any person who is accessing the account is first authorized, and then if he is authorized to use the account, then only he can access the services, right? So overall speaking, security is a very critical in cloud, because it helps to protect sensitive data, and it also prevents data breaches, ensure compliance and regulations. Okay, so talking about security pillar, it is I think it is one of the most important pillar of all 6 pillars. So uh, due to the following reasons. First of all, it protects sensitive data. If you have security aligned properly in your AWS account, so it will secure sensitive information, such as customer data, or intellectual property, or financial data. If you are storing financial data on your cloud, so it will protect. And unauthorized access or misuse of data. One is that if uh, talking about security pillar, if you have security uh, aligned properly, so it also reduces the risk of security breaches. So security breaches can result in significant financial loss, as I said earlier. So the security pillar helps to reduce the risk of security breaches by implementing various security controls and services, such as access management, encryption, and monitoring. There are several security services which you can leverage in your AWS account to avoid such activities, or such breaches, or scenarios. again, increase in customer trust is one of the valid point here, where strong security measures can increase customer trust and confidence in your organization. So if you have implemented a very a very strong set of security measures, you have aligned some strong security rules, so it increases customer trust. So customers are more likely to do business with companies that can demonstrate a commitment to protect their data and privacy. And lastly, it enables business growth. So a strong security posture enables business to grow by providing a foundation of trust and confidence. This can lead to increase in revenue and new customers, and expansion of the new market. So this happens by mouth publicity, where one customer can discuss this among the other around their network, where he can just say that this cloud provider or this partner has a set of security rules that they have protected our account since various attacks from various attacks. Next pillar is reliability pillar. So reliability pillar is one of the pillar that is focused on ensuring that the application and systems are designed in such a way that they are highly available, they are scalable, and they are fault tolerant. Okay, so this pillar encompasses several key best practices that help to achieve high reliability in your cloud architecture. So basically it means that following this pillar, you can say that you can achieve high availability of your application. Your application will scale at needs, and it will be fault tolerant. So again, some of the components, or some of the design principles that include reliability pillar are like foundations of reliability, where establishing a solid foundation is essential for building reliable systems. I mean, this includes ensuring that your infrastructure is resilient, secure, and compliant with industry standards, and it follows all the best practices. One is the workload architecture, which involves designing your application and systems in such a way that they are scalable, they are fault tolerant, and they are highly available at all times. I mean, this includes various techniques to do the to achieve the high availability, like setting load balancer, or auto scaling functionality, and caching to ensure that your systems can handle uh, peak loads and scale up or down on uh, on requirement. And where one point is one more point was there, like operational excellence. So operational excellence focuses on delivering continuous business value to customer through the use of best practices and automation. So these basically includes the automating process, where measuring performance and optimizing the efficiency and responding to the incidents very quickly, where you can uh, leverage some services where you are automatically notified if there is some incident, or if there is some high load on the server. uh, Testing is one critical part of the reliability pillar, where the testing includes, uh, especially for the scalability, as I spoke earlier, like the system should be scalable enough. They should handle the peak load, and they should scale at required time, where the server should not face any downtime. Okay, so you have to design uh, the architecture in such a way that it should minimize the downtime, or it should not have a downtime at all. Okay, so that ensures that your system can handle the demands of your workload. So in summary, the reliability pillar is focused on ensuring that your application and systems are designed in a highly available, scalable, and fault tolerant way, by following the best practices in the workload architecture, or operational excellence, monitoring and recovery, testing, and change management. So you can build reliable systems that can deliver high quality services to your customer by taking some design principles into account, which comes under the reliability pillar. Next is performance efficiency pillar. So this pillar focuses on optimizing the performance and cost effectiveness, basically of your cloud infrastructure and applications that you have deployed on the cloud or on the AWS account. This pillar includes several best practices that can help to improve scalability, efficiency, and cost effectiveness. So some of the key points that you can remember while considering the performance efficiency is that selecting the right resource types. So you can make the selection based on the application type. So selection of the right resources is quite crucial in ensuring that the application can scale efficiently and cost effectively. So by choosing the right resource type, such as instance type or database type, and the storage allocated, you can ensure that the application is optimized for performance and cost as well. Uh, Also, one more point in performance efficiency is that uh, you know uh, designing for elasticity and scalability, where uh, you have to design your applications in such a way that you can ensure that it can scale dynamically to meet fluctuations in demand. So this includes tools again such as auto scaling or elastic load balancing to automatically adjust the capacity as needed. Okay, so that can be done. Then optimization of storage is one another point where storage is again a very crucial aspect of any application, and optimizing it can have a significant impact on performance and cost as well. So this includes various tools such as Amazon S3, which is one of the storage service, object-based storage service of AWS, and retrieving data effectively and using appropriate storage types such as EBS volumes, EFS, and there are various tiers or various options available when you talk about storage. So selecting appropriate storage tier can also help in optimizing the performance and cost at the same time. There is also a way where you can tune your application or overall workload in such a way that it should effectively perform, or it will lie under performance efficiency pillar, that is effective use of caching. So caching can help to improve application performance by reducing the amount of time it takes to access the frequently used data. So if that data is already cached somewhere, by somewhere I mean the edge locations. So uh, caching can help in the data which is very frequently accessed, and use appropriate while if you are using appropriate caching policies, it will optimize the performance on the latency part. User will quickly get the landing page, or it will quickly load the application data. Then again, when we talk about servers, so there is always a uh, there is always a backend, or there is always talk about the database type as well. So selecting the right database is also one of the point where uh, you can optimize on performance. So choosing the right database type can again have a significant impact on performance and cost. This includes the AWS service managed service, which is AWS RDS. There is one more called DynamoDB and Aurora. So you can select any one of them based on your use case to rightly optimize the database requirement. Okay, so you by can optimize the performance and cost effectiveness of the cloud infrastructure and application. So it will ensure that they can scale dynamically to meet the demands of your workload. So the performance efficiency pillar again can help you optimize your system to deliver high quality at the lowest possible cost. So cost and the performance, both these aspects are covered in this pillar. Although there is a separate dedicated pillar for cost optimization as well. Okay, moving on to the operational excellence pillar. So this pillar, the operational excellence pillar, focuses on optimizing the operational aspect of your cloud. So what are the operational aspects? So this pillar includes several best practices which can help you security of your system basically. So some of the key components of this pillar are continuous improvement, which involves continuously evaluating and refining your process and systems to optimize the efficiency and reduce errors. So this includes various tools, such as automating and monitoring and alerting or identifying areas for improvements. So you can there are dedicated services for this in AWS. So you can make use of them, and you can reduce, or you can optimize the operational aspect of the AWS account. Then automation is one point where automation involves various automating of common tasks, such as uh, it can improve consistency. This can include tools such as cloud formation, which is one of the tool where you write infrastructure as a code, where you deploy the services using code. Okay. You can deploy various AWS services using cloud formation service, where you have to write a code, you have to give instructions, and the template will execute in a in such a manner that it will create the infrastructure for you. You don't have to go to console and go to each service and launch the service. It will create services for you on one click. Right. So monitoring and logging is also one point here, where monitoring and logging involves basically collecting and analyzing data from your infrastructure, from your current infrastructure and application, to identify issues and performance, for bottlenecks, and if there are any security loopholes. So these can include again services from AWS, such as CloudWatch or AWS X-Ray, to monitor the application performance and trace the request. Okay. And resource optimization is one point where it involves the resource utilization to identify opportunities basically. So if there are such resources where they are underutilized, so maybe you can downgrade them, or you can go for the savings plan. So resource optimization is one such point where you can uh, optimize the AWS workload performance based on the resource utilization. Okay. And last but not least, so there is one more point called disaster recovery. Okay. So disaster recovery uh, involves planning and preparing for the worst case scenarios to minimize downtime and data loss. So this is basically to uh, to control the damage that might be done if there is a region failure. So these includes, again, there are different services which can help to minimize the impact of disaster. The tools are AWS backup, and where you can create AWS backups, and there are various disaster recovery scenarios where you can, while setting up any account, or while moving to cloud, you can consider these scenarios based on the budget. Because setting up a disaster recovery architecture involves an additional cost basically. Okay. Last is not last, I guess. Yeah, this is the fifth one. This is the cost optimization pillar, which includes the ability to run systems to deliver business value at the lowest price point. So what this means is, these pillars focuses on optimizing the cost effectiveness of your cloud infrastructure, the infrastructure that you're already running with the applications. So these pillar include several best practices that can help to reduce cost and optimize your spend on the AWS services. Okay. So again, what are some key components, or what are some design principles that we should keep in mind to optimize on cost are number one, cost aware architecture, where it involves designing your applications and infrastructure with cost in a mind. Like, you have a budget, and based on that budget you design the architecture. Okay. So these include choosing the right instance types, storage types, and database services to optimize cost and performance. Also, as well as using the cost-effective services such as AWS Lambda, which is serverless service, AWS S3, and making use of CloudFront to minimize the data transfer cost. Okay. So right sizing resources is an important aspect when we talk about cost optimization pillar. So choosing the right resource type is very important when you are when you're planning to move to cloud. So uh, uh, I mean, this includes monitoring resources utilization, or even including tools such as AWS Trusted Advisor, or even Cost Explorer, to identify opportunities to reduce cost. Even if you have already launched and if you see that the application or the server is not it is underutilized basically, so you can downgrade the server and you can cost optimize there. So matching supply and demand part is one thing where it involves optimizing resource utilization to match demand and avoid over provisioning or underutilization. So these include tools like auto scaling, elastic load balancer, and spot instances. These are basically used to dynamically adjust capacity based on demand and using reserved instances to save the cost as well. So there are various savings plans, and there are various strategies where by applying which you can save on the cost. Okay, so yeah, so following these few best practices, you can optimize your spend on AWS services, and you can basically reduce the overall cost of your AWS workload, while you can while still delivering the high quality service. Can help you identify cost saving opportunities and implement cost effective strategies or measures to optimize your cloud infrastructure. Right. So last pillar is sustainability pillar. So this is a bit related to the environmental impacts. That uh, that that a public cloud has on environment basically. Okay. So to clarify, so this pillar focuses on designing and operating your cloud infrastructure and applications in an environmentally sustainable manner. So what does this manner say? Like these pillar include several best practices that can help you reduce your carbon footprint, or minimize the waste, or operate your systems in a more sustainable manner. So let's see one by one what are the key components or design principles of this pillar. So first is like effective use of resources. So efficient use of resources involves using tools and strategies to minimize waste and reduce resource consumption. So these include using serverless architectures, implementing resources, utilizing monitoring, and implementing automated resource optimization tools. So make use of such tools which will automatically analyze and optimize the environment in such a way that it should do minimum damage to environment. It should save energy. Okay, so talking of energy, the second most point is the renewable energy, where it involves using energy sources that do not emit greenhouse gases, such as solar or wind power, to power the cloud infrastructure and applications. So AWS, when it comes to public cloud, so when it comes to AWS, AWS is committed to using renewable energy to power its data centers and offer several services such as Amazon wind farms to help customers source renewable energy basically. Okay, and uh, uh, as I spoke earlier about carbon offsetting, where carbon offsetting involves balancing of the carbon emission produced by your cloud infrastructure. So uh, investing in such projects which reduces greenhouse gas emissions, you can do that can fall under the sustainability pillar, and you can help the environment in one way or another. So AWS offers a program called AWS Carbon Offset, which allows customers to offset their carbon emissions by purchasing carbon credits from sustainable projects. So this is one of the program that that is that AWS runs. Right. So by following these few best practices, you can operate your cloud infrastructure and applications in a more sustainable manner while still delivering the high quality service to your customer. So the sustainability pillar that we just saw can help you reduce your carbon footprint. It will help you to minimize the waste and contribute a more sustainable future for our planet. Okay. So this is an example of this is just a sample two-tier architecture, just to showcase, how how is the design implemented in cloud. Okay, so we have few components named here like VPC, virtual private cloud, where VPC is nothing but an isolated network where you launch the resources. Okay. Next is load balancer, which is again used for load balancing or redirecting to your application server. Next is internet gateway to provide the public access. There are public and private subnets based on the requirement. Like if you want to keep your application public facing, you can put that in public subnet, or if you can, I mean, if you want to keep it in private, or if the application is private, like in this scenario, the database server is in private subnet, so you can keep it private. Then EC2 and RDS instances, S3 bucket to store logs or backup, and you have Route 53, which is DNS service from AWS. Okay, so let's see one by one what is this, and what is the use of these services. uh, I mean, what is the main role of these services. Okay. So VPC, as I told, is a virtual private cloud that provides an isolated networking for your resources within AWS. So you can choose the IP address range, you can create subnets and configure route tables, and you can also attach network gateways, and you can have security groups to control the network access. So who can reach the server? You can control that using security groups. Next is internet gateway. This is a horizontally scaled, redundant, and highly available VPC component. Okay, that allows communication between your VPC and the internet. So if you want to have the uh, custom VPC, or your VPC component, then public subnet is a component where uh, it is public subnet accessible resources to be public, the internet nature. Suppose that to application public facing, you need to keep it in application is public. Private subnet is not accessible, usually used to host resources that require additional security, and it is usually so any resource service which should not be connected to internet is kept, or any to in private sub the RDS instance. Here is the RDS database. Uh, Example is and the load balancer, service that distributes multiple EC. This is serving traffic across multiple instances in multiple availability zones to ensure high availability and fault tolerance. Distribute traffic events. So EC2 is nothing but subnet. RDS managed is an operation. It is usually supposed to add. Next is S3 bucket service and retrieve any amount of basically a global APIs that as I'm offering from AWS, which allows you to route the traffic to your application resource based on the domain name or IP address. So basically it resolves the results into the IP, and it can be used to also route the traffic to the load balancer, EC2 instance, and other resources hosted within the within your VPC. Okay, so in summary, this architecture uses VPC with a public and private subnet and internet gateway to provide internet connectivity, and among EC2 instances and RDS instance to store data. I mean, it will act as a database, and S3 bucket which will store static content or logs or backups. Okay, so let's move ahead and see a use case, a customer use case uh, for on-premise to AWS migration. So a customer who has migrated the infrastructure from the on-premise to AWS. So yeah, so Netflix, as you all know, is one of the most well-known and successful video streaming companies in the world. So it has more than 200 million subscribers globally today, and the company transitions to the AWS cloud is an excellent use case of demonstrating the benefits of cloud computing itself. Okay, so whatever benefits Netflix has received using cloud computing, we'll see that further. So what was the use case why Netflix decided to move to cloud? Is that before before making the decision, like before moving to the cloud, Netflix had a traditional data center. Okay, so it has a traditional data center infrastructure that required significant maintenance and scaling efforts. So the company's massive user base meant that it needed to handle enormous amount of data. The data was increasing day by day, and it was getting difficult to handle that amount of data. And scaling was one of the concern, where infrastructure needed quickly scale to meet the demands of the customer. Sometimes customer would experience the buffering of the video or the content. So until they come up with a server, the customer was not able to view the content, and until that there was that buffering period or the latency. Okay, so to address these types of challenges, Netflix decided to move its entire video streaming infrastructure to AWS cloud in 2008. So the company chose AWS cloud because of the scalability, reliability, and global reach, and and it started migrating the applications to the cloud. So today Netflix has variety of AWS services such as EC2 service, S3 service, RDS service, to store the content. The company also uses Lambda, which is a serverless computing service. Also, you make use of CloudFront for content delivery. DynamoDB for NoSQL databases. So basically, by moving to cloud, Netflix has been able to achieve a significant benefit. Some of them are scalability. I mean, obviously, the pain points were turned into the positive, or or turn into the pros when they move to cloud. So scalability was achieved where AWS provides Netflix with the ability to scale up or down quickly based on the user demand, and it has helped the company to deliver high quality video streaming to millions of customers around the world today. Okay. Flexibility was one concern where AWS allowed Netflix to use variety of services to meet its specific needs and to experiment with new services and features to improve the platform. Then cost saving was one concern where AWS helped Netflix to reduce the infrastructure cost, okay, significantly by only paying for what it uses and eliminating the need to invest in expensive hardware or data center. So earlier, Netflix used to invest a lot of money, to maintain the hardware or to buy the hardware. So now the cost cutting was done on that part as well. Next big thing was the global reach. So AWS, as AWS has a global presence, so it has helped Netflix to expand its services to new regions and reach more customers worldwide. Okay, and reliability was one concern where AWS provides Netflix with high reliable infrastructure that can withstand failures and ensure that its video streaming services are always available. It does not face any downtime also. So in summary, Netflix use case for moving to the AWS cloud is one of the excellent example of how a cloud computing can help companies to scale quickly, reduce cost, and improve the reliability and flexibility of their infrastructure. Right. So to conclude this presentation, I would say that a well-designed cloud architecture is a very crucial for building scalable, reliable, and secure cloud-based solution. So it requires a deep understanding of the business requirement first. What is the use case, what is the technology stack, and what are the cloud services that are available in the cloud service provider. So a comprehensive design process includes identifying and prioritizing the requirements, selecting appropriate cloud services, designing the infrastructure, and then implementing it. Okay.
Okay, thanks Vishal and thanks Putuja. It was really an informative session. I hope all our attendees have found it useful. And thank you all for attending the session. Cloud.in is an AWS advanced consulting partner, and we have extensive expertise to architect, deploy, migrate, and manage workloads that provide unique, innovative, and personalized experiences. Do contact us at sales@cloud.in to discuss further. Thank you again and have a great day.
Yeah. Thanks all.